Hello, everyone. I'm Emily Berry from the Miami University Alumni Association. As part of the MUAA webinar series, today Miami Women Initiative is proud to present Making Data Meaningful. We are pleased to have us joining us today, Amanda Makulec. I should have asked you how to pronounce your last name, Amanda. Would you please introduce yourself?
Hi, I'm Amanda Makulec.
Makulec, thank you. Sorry about that. Class of '08. Amanda is a data visualization designer, teacher, and speaker, and is the executive director at the Data Visualization Society. Welcome, Amanda. Thank you so much for being here today.
Thanks for having me, Emily. I'm excited to have a chance to share some of this world of data visualization that I did not know existed as a career path when I was at Miami, but seems to have become a bit more popular these days. So excited to dive in.
That's so great. As a reminder for our live viewers, you can submit a question during the webinar by clicking on the Ask a Question button under your video, and I will relay those on to Amanda. And with that, I will turn it over to Amanda to get us started.
Wonderful. Thanks, Emily. It's great to be here today and excited to have a chance to go ahead and connect with all of you about this topic of data visualization and making data meaningful. I think as we think about data visualization and data viz in the world around us, I think it's really important to recognize just how frequently we engage with visual information, whether it's quantitative data or qualitative information, every day in our world, not just in our work. And so as we dive into our conversation today, I hope that you'll find things that are useful and meaningful for you, whether you're joining just out of interest and curiosity, or you're joining because you yourself do create data visualizations as part of your work. So let's go ahead and dive in and get started and talk a little bit about a t-shirt, which seems like a strange place to start with a data visualization talk, right? At the Miami University bookstore, back when I was in undergrad in the early 2000s, there were various iterations of this shirt around. We were a college when Florida was a state. Miami was a university when Florida belonged to Spain. And an iteration of this shirt was one of my dad's absolute favorite t-shirts that he always enjoyed wearing. And he enjoyed pointing to people who would joke about asking if I was in school at Miami, Florida. He would go ahead and he would instruct them and share a bit of history about the timeline of Miami's founding. And I think about my dad a lot these days because he passed away last week. And so I'm carrying a lot of that today as we go into today's conversation. And I think it's a wonderful thing to think about the ways in which the world around us and the different mementos and things that people leave behind also make you think about and connect to your world in different ways. And so when I was thinking about Miami data and Miami themes for today, and we'll dive into various different kinds of Miami data, one of the things I thought about was this t-shirt and this simple piece of text that says Miami was a university before Florida belonged to Spain. And when I see that shirt now and see that with my dad wearing it and think about all the times I saw him showing up at Miami events or showing up at other family events wearing this t-shirt, ways in which that text encodes actually a lot of data and information about history, right? And that's the way my brain works as a data viz designer. I see opportunities for visual information everywhere. And so as we think about what that looks like, we could break that down into a timeline, right? How long has Miami University been in existence compared to when the state of Florida was created, when it was a US territory, and when it did actually still have colonial occupation by Spain. And that data visualization tells me what was on the t-shirt. But a great chart actually shows as much as it hides. And so as we think about what's missing here, we're missing other components of what that history looks like in terms of the colonial history of Florida. And we're missing on that chart the many thousands of years of indigenous land ownership that happened in Florida far before Miami was actually created as a university. And the way that my brain works when I see various different pieces of text and information is how would I plot that out visually to try to encode more information and detail in that, in how I might communicate that data. And so as we think about the places that we draw from and the inspiration we take as we build different kinds of charts and graphs and visual explainers like this one, we can borrow from various different major practitioners throughout history. This curved actual chart is reminiscent of some of the Du Bois bar charts that actually curve back and forth. If you don't know the work of W.E.B. Du Bois, I highly encourage that you dive into it. We won't have time to dive into it deeply today, though. And so what I want to focus on is the ways in which I really believe that everyone can learn to be better readers and creators of data visualizations, and hopefully give you some ideas and tips and tricks for how you can do that in your work and how you can notice some of the seemingly small design decisions that designers make in creating these kind of visual representations of data. During my time at Miami as a class of 2008 grad, I was a double major in zoology and sociology. And as I may have mentioned at the very beginning to Emily, I didn't know my job existed back when I was at Miami. I've always been curious and interested in this intersection of art and science, data and information. And that double degree in zoology and sociology sent me down a path of studying public health, getting my master's in public health at Boston University, where I got to continue having red as my core university color. And then going ahead and going on to a career over the past 13 years in public health, primarily focused on data visualization design. During my time at Miami, I was a member of the Chi Omega fraternity and still am an active alum. And I was also on the Panhellenic Council. And so you'll see little bits of that history and my curiosity around majors and around Greek life in some of the data visualization examples that we'll talk about today. So let's talk for a bit to start about why we love visual information. What are some of the key reasons why we engage with and see patterns in information so quickly? Then let's talk a bit about how anyone, you too, can build a better chart or graph, a tool agnostic approach to thinking through the design decisions that we make when we're creating and curating data to present and communicate a key analysis finding. And last, talk a little bit about who creates data visualizations. Like I said, I didn't know my job existed when I was at Miami. And maybe for some of you, you think this is a practice you want to bring more into your work. Maybe for others, you're instructors or educators yourselves and want to be able to share more about this kind of STEM career with people who are in your classes. And so let's dive in first around why we love visual information. Why is it that we connect so much and see patterns in information so easily and so rapidly? If we think about one of the most common ways that we engage with data visualization and visual information, it's on maps. That's oftentimes one of the early exposures that we have, seeing information plotted visually. And paper maps are how we used to navigate the world around us, right? When I was a kid growing up in the Midwest back in Northern Illinois, not Chicago, but Northern Illinois, farther through the cornfields, we kept all of these Rand McNally atlases and paper maps in our glove box for Illinois and Wisconsin. And you'd have these little overlapped sections where kind of you could get Illinois and Wisconsin on the same map. And then to get to the North Woods, you'd have to have a new map. But we had these paper maps that helped us navigate the world. And eventually we evolved how we engage with that information. Out came MapQuest and other ways that we could get printed out directions, hang them on our windshields, and in retrospect, ask big questions about how it is that we actually all survived driving in those kind of situations with the amount of distraction that we had with T9 texting and the various different printed out instructions. But the way in which we started navigating the world was different. We got more bespoke information presented to us, optimizing routes for time eventually, and helping actually map out a turn-by-turn set of directions. And today that looks very different, right? We have Google Maps on our phones. We have inbuilt navigation systems within our cars that take and use a lot of inputs of data, information about distance, time, latitude and longitude to plot where you are, traffic density, and all of the layers of that base map that include all of the streets and the other features that you are navigating around as you drive from point A to point B. And so we all need directions still. Our need for directions has not changed, but how we access them has. And something similar has happened in the world of data visualization, where we have many more ways to access charts and graphs and visual information than we had 10, 20, 50 years ago. And we all still need different kinds of information in our work and in our lives. And so as we think about what that functionally means, that need for information and our interest in seeing it visually, there are many ways in which we can communicate things better now than we might have been able to 50 years ago, in part because of our access to technology and the tools that allow us to rapidly iterate and prototype different kinds of graphs and charts and dashboards. But regardless of what the visual product is that you're making, we all want to think about a couple key things that help some charts and graphs just communicate more effectively. And those are different pre-attentive attributes, the thinking with your lizard brain and leveraging our precognitive processing that we do when we see something on a page or a screen, and we want to go ahead and before even thinking about what is it that it means, what is the text that's written, seeing a pattern in that information. And so one of the simplest ways to communicate this and test this out is to look at a table of numbers. So here's a simple table. And go ahead, I'm going to count slowly for about 15 seconds. How many number 5s can you find in that table of numbers? All right, you should have an answer now. Now, if I go ahead and I make a tiny design modification and change out how I formatted that table, highlighting the number 5 with color and with bold text, you suddenly don't even have to read the numbers anymore. You can just scan and look for where you see that bright, bold blue spot jump out. Now, that assumes that you actually can trust me as a data visualization designer and that you trust that I have actually colored in every number 5, which a couple of you might now be looking and seeing if I actually did, which would be a fun trick to play. But this is because, and the way these jump out is because color is a really powerful pre-attentive attribute. It allows us to quickly see and scan patterns in information, dense amounts of information. And we encode color in different ways, including hue, lightness, saturation, intensity, allowing color to actually show us different patterns and discriminate between different data series or different categories. We also use location in data visualizations, and we leverage the Gestalt principles of perception and the ways in which our brains try to create order out of disparate objects and curate them into groups. Now, that's a lot of fancy words for saying when I look under those examples for proximity, and we look at these different samples, you can see that when I try to create collected groups of different small dots and create 2 separate groupings, your brain will immediately think, well, there's something similar about that first larger group and that second smaller group. We also use features like closure, like a box around those gray dots, to say there's something similar about these gray dots. You should look at them together and see what the pattern is. Also looking at continuity through space, like drawing a line with your brain between those different blue dots, looking for that continuous line shape. Or even things like connection, where instead of seeing 9 disparate objects, 3 circles, 3 lines, and 3 triangles, you probably read that as 3 kind of road sign shaped objects, 3 individual objects because of the connection of the line between the circle and the triangle. And so as we think about location, location is powerful because if I give you a big number with a chart next to it, I'm telling you by putting white space around those things that you should read those 2 things together. We also look a lot at form in data visualization and use different visual forms to represent information. This is a series of different examples where A, B, C, D, and E all encode the exact same percentages. But take a minute to scan and look. How easy is it to compare the relative size of circles A and B under area compared to the length of A and B on an aligned scale bar chart? We use different visual forms or encodings like bars, circles, angle, weight, area to encode information and present information in different ways. And some of these encodings have greater precision visually for us in how comparable they are than others. We also use things like motion. Motion allows us, the joys of Google Slides. Motion will allow us to actually see the path through which something happens and the speed at which something happens. So imagine in your head, with little purple balls in the upper left corner and the little blue balls in the upper right are falling down those 2 different pathways. Now the green pathway has fewer stopping points and is green, enabled, moves quickly. So it's got color encoding a visual cue there. And the red and orange side actually has more stopping points that you can visually see with the word stop, and has that red and that yellow, that orange that says something's wrong here, something's not as good. And if you can imagine there being different little balls falling down to encode motion, the purple balls in this graphic fall really quickly and move really rapidly, whereas the blue balls fall really slowly. This encodes information or data in the speed of motion at which the pace those balls actually fall down those pathways. And once you start identifying these pre-attentive attributes in charts, things like form, color, position, motion, you'll actually start seeing them everywhere in the world around you, not just in charts and graphs, but also in wayfinding signs and how you might navigate a metro rail system. So we take these pre-attentive attributes, these various different encodings of information, and think about the ways in which we can build better charts and graphs, leveraging that pre-attentive processing in ways that we can help people see patterns in information before they even realize they're seeing them, and take additional steps to use purposeful color and meaningful text and decluttering our charts and graphs to help people focus on the key data story that we're trying to tell. When we're going ahead and we're creating effective charts and graphs, we always want to start with the question of who our audience is. What's going to resonate with your audience? What is their level of graphicacy, their ability to read charts and graphs, or data literacy? How familiar are they with the various different pieces of information you're presenting? And then we want to think about the mix of that audience and the kind of data story you want to communicate. Are you trying to communicate a key finding around a part to whole comparison or around a trend over time, which lend themselves to various different chart types? Chart taxonomies are tools that you can use, especially if you're newer to data visualization design, to classify and group different charts according to function or other features like shape. There's earlier forms of chart taxonomies that are relatively simple. This is one that ran around years ago. That has a schematic that looks at different chart suggestions on looking at what you want to show, a relationship, a comparison, a distribution, or a composition, and then breaks down the different chart types that might work well in these different examples. More modern versions, created more recently, expand on that same principle and idea, this example being from the Financial Times and their visual vocabulary, and show you the various different charts with a little descriptor or piece of information that may work well for different kinds of presentations of information, different data stories, change over time, a part to whole comparison, something spatially, looking at geographic data, or something where position really matters a lot. And what's great about the visual vocabulary in particular, especially for those of you who are exploring the data viz world or maybe who are instructors, is you can actually look up and find where people have built whole Tableau or Power BI notebooks that have all of these different charts already pre-built, so you can see how to build them in a different tool. Then there's interactive spaces like the Data Viz project, where you can actually sort by things like shape. And I can look for all the different circle-shaped charts that might allow me to go ahead and see different kinds of information. And clicking into any one of these will allow me to dive in and read more about how it gets created and see a library of different charts that use that specific chart type. So these different chart taxonomy tools are so helpful if you're looking to brainstorm ideas for what kind of information you might present. We also want to ask ourselves, back to that visual precision question, how visually precise does the form need to be? And here what we really care about is, say, if there's a 1% difference, or a tiny minute difference between two values, is it important that our reader can really see that small minute difference? Or is the importance of broader kind of picture of the patterns in the data, the relative sizing of one value being really big compared to all the other individual values being really small? As we think about what this means in practice, we can actually take various different visual forms and plot them along this continuum of comparability. A bar chart on an aligned scale that you see on the far left is a really easy way to present very precise ways of comparing different values. So if I want someone to see the difference between 97 and 98%, I'm going to use something more on the accurate end of the comparability spectrum, an aligned scale bar chart. The minute I start misaligning these, though, as happens actually when we build a stacked bar chart, for example, where the second or third categories in the stack actually are on a misaligned scale, we suddenly don't have quite the same degree of comparability. And working across, we then can look at length, the relative length of different sections, slope, where we look at things going down. Both of those lines are going down, but I can't tell you the exact slope of by how much they went down. Angle, we're comparing those two segments near the top, the blue and the gray, might be difficult because they're both small-ish segments. And we typically read the angles on pie charts along, kind of like we do a clock, the 12, 3, 6, and 9 points, giving us proximity, kind of proximal spaces for looking at what a 25% arc is. And then further across over to things like area, volume, and luminosity. When you plot information on a map, we often use luminosity. We use various saturations of a given color, where the darker colors mean a higher value. And that's very common. That's well understood and for folks who are accustomed to reading maps. It's not a bad way to encode information. It's just a more relative scale than what we might get if we plotted other more precise values, which means that it's even more important to give people clues as to how to interpret that data, making sure that you provide them with information like a legend that says, here's the value or range of values encoded with the darkest blue compared to the third darkest blue. So let's use a very Miami example to go ahead and talk about what these principles mean in practice. Because I think one of the best ways to explore the world of data visualization is to get into the head of how a data visualization designer thinks and goes through the process of making different design decisions, which you can adapt into your work if you're creating charts and graphs. So let's start with who we're talking about and who our audience is. As a Miami alum, what kind of university information is interesting to me? What would I want to know? That was the question I asked myself when I was prepping for this presentation. And I decided I wanted to think about and look at and understand how the popularity of majors has changed over time. In part because, my majors, my zoology and sociology double major, have actually served me pretty well working in public health. I pull in some of the kind of biomedical sciences pieces of the zoology major with the health part. I pull in more of the data and the research side of things with my sociology major, and it's all worked out just fine. But I was really curious to see if there's been, say, a growth and interest in STEM majors, for example, or what other areas are growing or shrinking across different majors at Miami. And so the second thing you ask oftentimes when you're mapping out who your audience is why you want to know. So I'm motivated by understanding something about some of the fields relevant to me. So have some of the fields relevant to me actually grown or shrunk in terms of their share of the overall pool of majors in a given year? And figuring out kind of why someone wants to know that information. And asking that why question is really important because it often drives some of your design and formatting decisions. So as you think about who you're communicating with, making sure you have a clear example of who your audience is, what question they want to answer, and why they want to know that information are three key things to think about whenever you start to build a new chart or graph. And this shouldn't take a ton of time because if you're building a chart or graph, you should have a reason for doing it, right? So I went ahead and dug around looking for some data, and lucky for me, there's a wonderfully kind of curated common data set that's put out each year by Miami and many other higher education institutions that goes ahead and provides some snapshot data about what's happening at a given point in time at the institution. Now, the challenge is, if you look at this in available years, we've got 10 years of past data. The data is all in downloadable Excel spreadsheets, so not really time series per se that's easily accessible. And we have the challenge that we only go back to 2013. So my goal in my head had been, let's look for data from back when I was at Miami in the early 2000s. That wasn't quite easily accessible. So let's look at the past 10 years and what's happened. So here's what's in the spreadsheet. We've got a data table that gives us information about degrees conferred within a given period. So we're looking at July 1st, 2021 to June 30th, 2022 for the most recent data set. You can see there's a nice descriptor up there of what this actually means. And we're looking here at the share of degrees conferred. So you can look across those bachelor's degrees. And what it will do, because you're looking at share of degrees, is it allows you to actually count someone with multiple degrees in their respective degree programs. So you're not only counting each person once, you're counting based on the unit of degree. And whenever you're working with data, spending time to actually read the notes and make sense of what the information means is important to make sure that you understand the data that you're working with. Ideally, understanding more about how it gets collected. So we can see on this data table, we have a number of categories that are standardized across institutions. So this doesn't look quite the same as a list of Miami's majors, but rather the more macro level categories. And we can see, we'll focus here on the bachelor's degrees that were conferred. So looking just at the bachelor's degrees. And given that I just have one point in time for this specific piece of information, and I have lots of categories, you can start by plotting that and thinking about chart ideas as a bar chart. So we see business marketing as the most kind of popular degree in terms of the most degrees conferred, followed by health professions, then social sciences, et cetera. You can see a pretty big delta, right, in between business and marketing and the other programs, given the popularity of Miami's business school. But going back to the question I asked myself, how have things changed over time? I need to layer in some more information because there's nothing about time on this chart, right? Sometimes we need to go find more data and blend data together to actually get at what our audience needs to know. So we can go ahead and we can add in a background additional data series. This is an overlapped bar chart that allows us to see in the background what the data looked like for 2013-14, and then what it looks like now. But this gives me the ability to see both things, but it takes me a minute to sit there and kind of focus in and look and see what happened in education. Why did it go down so much? English went down. I really lose the kind of background shading of the values where it went up, just by nature of them being hidden behind the other bars, even with the different spacing. So maybe this isn't serving me entirely to really focus on the difference. So what if I changed my encoding so I wasn't obscuring part of that background bar, and I did a dot plot? And this would be called a Cleveland dot plot based on the person who originated it, where we actually plot each of those two series, the most recent values and the values from 10 years prior. We plot those series as two separate dots, the darker black dot representing the most recent series and the gray dot representing the previous one. And now I can start to see kind of gaps in between them, and I can clearly see both points in most cases, except for where they're really close together and there hasn't been much change. So this gives me a different way of plotting that same information that maybe gets me a little bit closer to my analysis goal with this dot plot. Now, I don't see that big bar for business marketing jump out at me quite as much, right? You have to kind of look for it because it's so far down off there to the right-hand side. But it does start to get me closer to my question about how the kind of popularity of degrees has changed. And we can connect those two dots by creating something we call a dumbbell chart. And a dumbbell chart is going to then encode the delta, the difference between those two values, with a line. And it will show us the difference in between those two such that we can see kind of as we scan through where we've seen some increases or decreases. And it focuses on the shape of each little data series, which ones have had big changes versus which ones have had smaller changes, getting back to the relative comparability of different encodings of information. I can really see very granularly rank order those black dots in terms of the order of the values. But the lines, because they're offset, I kind of have to guess at the relative differences between them. But this starts to get me closer to something I can work with in terms of answering my question about the change in the popularity of majors. So let's talk about what we might do with this dumbbell chart, if that's the chart choice we make, what we might do with this dumbbell chart to help make sure it communicates effectively. So we want to think about how we sort that dumbbell chart. We could try sorting it based on the delta. So this is the difference between the previous period and the most recent one. But this starts to look like a little bit of a mess. And I lose some of the rank ordering of the kind of the overall shape of the popularity of the majors, which is a secondary interest. And it just becomes a lot harder to read. It feels less organized, right? And sometimes we think about how charts and graphs make people feel, because if things feel and look disorganized, that can be a real turnoff to someone engaging with that information. So let's stick with our original sort order, where we're sorting based on the current share of bachelor's degrees from that most recent data period. So we get that effect of a ranked list of various different majors. Now, the next thing that we do, and after we sort, and I've kind of done a bit of this for us, because you'll see in a second, is we declutter and really shape what the chart looks like. I built the dumbbell chart in Excel. I'm a big believer of using tools that everyone has access to, and I'm happy to provide access to the workbook if anyone wants to see how it got built. But as you go ahead and you look at this chart, this is what that chart looked like, this one, before it actually got finessed and kind of formatted and recreated. This is built as a scatter plot, where we plot each value on an XY coordinate plane. So we have an X value and a Y value for each of those individual rows of data. And then we use those green dots off to the side to add our additional labels or category labels. But you can see we've made some deliberate design decisions here that may seem small, but kind of disappear in some ways, but are important. We have some grid lines that give us some order in the sense of reading what the various numbers are. Since it's really tall and there's a lot of values, it's helpful to have those reference points so we can see just how one value compares to another, or to a reference point of 5%. We can also go ahead and we can see that there's no line along the x-axis that kind of cleans up and removes that little piece of visual clutter. We have a left-aligned list of categories rather than having them offset at various different spaces. It's a left-aligned list of categories that functions as a ranked list of popularity of majors. And we've kept things pretty simple in terms of keeping and getting it right in black and white first. If there's one thing you take away as a chart creator from this webinar, get it right in black and white. Get the shape of your chart quite the way that you want it to be. Then add color and text and other features in with purpose. So we declutter our charts and graphs to focus in on what the core shape of the data is. Then we think about adding purposeful color. So what do we want to add in terms of what story we're emphasizing? Do we need more than one color to highlight different categories? And how has a given color been used in other parts of a slide deck or a dashboard that there may already be a mental model for what that color means? And we'll talk about the challenges of mental models and these red color palettes at all the schools I've attended my entire life in just a minute. So as we think about color types that we might use, we can do things like using sequential color palettes where we have data encoded in the color itself from a low value to a high value, or a diverging palette starting with a neutral midpoint at the center, like gray, and then having two different colors representing higher and lower values. We also use categorical values or color values where we use different colors for different data series. And some of my favorites, using highlighting and alerting colors where we make most of the chart gray or grayscale. And then we add color in to add visual emphasis to various different points within the chart or graph. Again, leveraging that pre-attentive processing that focuses attention with color. We want to think about color blindness. Are we making sure we're not using red and green right next to each other, which may make it hard for some of you to read if you're some degree of colorblind, the numbers on these circles, 7, 13, 16, 8, 12, and 9. And we think about contrast, not just thinking about color, but also contrast between the text that we use on our graphics and the background colors themselves. This is 3 examples from the WebAIM contrast checker. It's one tool you can use to check and see if the text you're using or the foreground shape is a high enough contrast against the background color. And you can see which of these actually pass a contrast check, like black on a white background, versus far to the right, where you see the gray on a white background, where it's really hard to read. Just try to read the 5 boxing wizards jump quickly. That's really difficult to read with that gray on white background, despite the fact that somehow the data viz world has made it very en vogue to go ahead and present information with that kind of gray text on white. I guess it looks sleek, techie, I'm not sure. From an accessibility perspective, it's not great. So we can use color and bring color in terms of how we might highlight different values. So here I've used red, Miami red, to highlight the various different majors that have seen an increase, bringing attention specifically to the 3 majors that have had the largest increase over the course of this period of time between the 2 available data sets. Now there's a key challenge with the use of red that way, right? Think about how you usually think about the color red. What does red mean to us? Red usually means negative, gone down, bad, alarming. These are all challenges that we face if we work in environments where either our brand colors or our other colors that we're assigned to use don't quite align to what our mental models look like. So always be mindful that if you are going against what a mental model is that someone has, using red to highlight something good, for example, that you need to make sure you're adding clear text and information to communicate the key findings such that people don't misinterpret why those different sections are highlighted. So we see here that we've got some bold text highlighting those 3 sections with color. So we're drawing attention to 3 specific majors in this long list or groups of majors. And we've added that red text to indicate the increase by a certain number of percentage points. We can think then about other meaningful text we might add beyond those additional labels that show that percentage point increase, and think about the ways in which we leverage the space we have on our chart to tell someone what they need to know. If you go ahead and you look at this graphic, looking at some research that was done, let's go ahead and focus in on those bright pops of yellow. So this graphic is showing us eye tracing data, looking at how someone read a chart and a map, the top row and the bottom row, and where they looked in the first 3 seconds, next 3 seconds, and final 3 seconds of a 9-second window. Your eyes go up to that upper left-hand corner. That's where we go first when we're looking for information. Whether we're looking on a map or we're looking on a chart or we're reading a book, think about where we start our text on a page. We have a mental model to read that corner first. So when you're building a chart or graph, think about the ways in which you can leverage where someone's eyes go first by placing your headline or your title in the upper left-hand corner. We also think about visual hierarchy. Give this slide a read for a second. We use different fonts and text hierarchies, size, contrast, to draw attention to different pieces of information. So be thoughtful about the hierarchy of text in your titles and subtitles on your charts and graphs. Here we might add in a kind of a little teaser title, How Have Miami Majors Changed Over a Decade? Expanding out the kind of 10-ish year window that we're looking at. And then say that health, communications, and computer science, expanded out with their full words below, show the largest gains in annual share of bachelor's degrees over the past decade. And then we give a little legend below that tells us what these various dots mean, having a little bit of the challenge of what we mean when we're thinking about the red and the black and how we might want to encode that. We may need to add a second dot there, for example. And so as we look at this and we think about this chart and how it's communicating, we've added additional text at the bottom with an axis label and added additional text at the bottom indicating where the data source was, embedding that within the chart itself. And as we look at how we kind of bring those different features in, we can go to places like a brand or style guide to help to determine what some of the various different font choices might be or what the various different color decisions are, recognizing that not every different color in a branding style guide might be the best for a data visualization. We have to adapt things a little bit. So let's compare where we started with our ideation process and where we ended. We started with a basic bar chart that we then evolved into thinking about adding additional series as an overlapping bar, a dot plot, and then a dumbbell chart, and then spent time going ahead and decluttering, focusing with meaningful text and purposeful color to tell a clearer data story in terms of telling someone what they need to know. Now, this isn't the only right way to visualize this data or to communicate this information. You could start to reduce down the number of majors that you're showing to reduce down kind of how much information is presented. You could refocus on a different part of the story. Why did education go down so much? And part of building a great chart is to prompt additional questions sometimes. So because we can't answer the why about why did some of these have big gains or losses, maybe it's the market and market demands, but maybe it's also a change in the size and the scale of the program. Maybe something new was introduced or something was sunsetted. And only someone with the actual knowledge about the history of what's happened over the past 10 years could tell us some of that information, which is where I think humans in the loop, not just relying on AI to tell us everything we need to know, is really important. As we think about why we make these decisions, thinking about how we declutter information is not just rooted in making prettier charts. It's rooted in data and research. So Cole Nussbaumer-Knaflic, who wrote Storytelling with Data, which is an excellent primer on kind of simple business graphics, along with Steve Frankenary and a team at Northwestern University, tested out to see what the recall and memorability was of different charts that were decluttered and focused in different ways. And a cluttered, simple chart like this with some design defaults, when they asked someone to redraw it, people were really bad at redrawing that chart and trying to tell someone what the key finding or message was. And they tried out a second version of the same exact chart, decluttered and simplified down into grayscale. And they asked people to redraw it again. And the memorability and recall was similar to the performance of the cluttered chart. But when they decluttered and focused that chart, and they said, here, focus in on these blue sections, here's some additional labeling and text, people were far more likely to retain the key point than they were when they had this really cluttered graphic. And so as you think about why you might take the time to customize and make some design tweaks to a chart or graph, we want to think about the ways in which doing this actually enables and reduces cognitive load and enables memorability of our charts and graphs. We can take a simpler chart, maybe looking just at 2 data points. So like I said, I was involved in Greek life. So let's look at kind of the percentage of men who join fraternities and women who join sororities, looking above at what this data table comes from, same data source, but focusing on first-time, first-year degree-seeking students. And so as we look at what those values are, we have 2 numbers. We could plot those into a basic bar chart. And the default chart that Excel will pop out for you when you build that basic stacked bar chart is there on the left-hand side. And then the other chart is over there on the right-hand side. You see there was even a data error in terms of flipping them around and what the actual values are and what that looks like. We inverted kind of the ordering and focus on sororities first and then fraternities. And as we go ahead and we look at the various different design decisions here, making those seemingly small changes, decluttering, removing some of the grid lines, simplifying down the labels, going ahead and adding a key takeaway title. Those are all things that don't take a lot of time, but add a lot more in the sense of what someone can take away from this chart or graph. So key message here around the larger share of undergraduate men who opted to join a fraternity compared to the share of women joining a sorority in that fall 2022 time period. We could also change the story here instead of focusing on a comparison between sororities and fraternities and do a part to whole comparison with one piece of that data. Now, the default pie chart that Excel is going to pop out looks something like this on the left-hand side, with percent of undergraduates as the title and then additional information below. But by having some kind of clearer labeling on this donut chart and telling someone the key takeaway with that center label and that big number, we focus their attention a bit more. We could even go to a frequency framing approach where we say 2 in 10 women. That's about the same as 20%, right? 2 in 10 women join a sorority, or simplifying further, 1 in 5. And by moving to a frequency framing approach, 1 in blank, 2 in 10, we enable people to better kind of think about and connect with what that number is. 20% sounds really small, right? When you think about 20%, that sounds like a small number. But 1 in 5, I mean, I can sit at a dinner table with 5 people, and one of us at the table would have been part of a sorority. And so as we start iterating on different chart types, the possibilities with the tiny data table, these 2 numbers, are really endless in what we can do. And taking the time to go ahead and not just use those design defaults that the tool gives you, and instead focusing in on those key messages and takeaways are really different. And so as we think about what this looks like and means and how this kind of translates into our world, we want to think about the ways in which there are no kind of precise rules that tell you every choice you should make in data visualization. There's various different ways in which we take and apply different ideas or make different choices in meaningful ways and build better charts and graphs. Alberto Cairo is someone who's a leader in our field, a professor of journalism at the University of Miami, the actual one in Florida. And he has talked a lot about this pragmatic shift in the world of data viz, that designing visualizations isn't about rules and one of us telling you exactly what you have to do, but rather about making justifiable, ethically and functionally choices according to certain goals and within various constraints. And that oftentimes when you ask a great data visualization designer what the best chart type is or the best color palette is, they'll always say it depends on who your audience is and what you want them to know. So let's talk about, as we close out, who creates data visualizations and who those people are, people in my field, people like me, people who have very dramatically different jobs than I have, but still are data visualization designers. Data visualization can be a skill that you have in your toolbox. Many of you perhaps have been asked to create a chart or graph at work at some point, and I think everyone learning some basic data viz design skills can just make the world a better place. Less death by PowerPoint, right? It also can be a full-time job, like what I do, where I spend all of my time creating, teaching, and coaching on data visualization. And as we think about what those different jobs are, there are many jobs that actually connect back to the world of data visualization, building different kinds of graphics, some explanatory in nature, kind of schematics and frameworks, some more exploratory, like business dashboards, and some rooted more in conceptual ideas, and some rooted more in thinking about that really specific quantitative information. And this is just a smattering of some of the job titles you might find if you're looking for a career in data visualization: a data artist, a UX designer, an analyst, a business intelligence developer. And I like to think that all of us are kind of data curators. We help make sense of the immense volume of data that's out there in the world today. And yes, I might be a bit biased, but I think that there's meaning in doing that, in helping to demystify the world of data, make people a bit more data literate, and help people connect with information. And to do that, we have a lot of different skills: storytelling, communication, analysis, data discovery, all these different things that we spend time doing. And as you think about this wheel of various different data skills and capabilities that people have, within the Data Viz Society, we did a series of interviews on career paths. And these are these little mini data portraits of just a sample, 12 of the people we interviewed and talked to. And you can see, not focusing on any one section, you can see how different they all are, because people have such different skills and experiences depending on what your role is in this field, in this world. It's tough sometimes when it's not super well defined, to be honest. And the fact that the same job title in multiple companies might mean very different things. But it's exciting to see that there's such diversity of thought and ideas in our field and what that looks like. And in a world where we're living by AI prompts, things like imagine a beautiful dashboard, I still think there's a role in thinking through the ways in which we keep humans in the loop. We can imagine a beautiful dashboard. Midjourney did in this case, courtesy of my chart chat colleague, Andy Cotgreave. And I'm not sure I'd want a business dashboard where about a third of the page is occupied by a whale. Instead, I want to think about the ways in which I might use AI in more meaningful ways, where I can actually dive in and explore the many terabytes of data that are created each day by looking for quick patterns in information and then bringing humans back in the loop, so that we think about the ways in which we don't just create charts and graphs for the sake of building them and making pretty data, but instead to enable conversations and to sit at a table and talk about, well, why did those different majors gain or lose people over the course of the past 10 years? When we think about why this matters in the context of business, a Data World survey looking through Harvard Business Review found that 90% of business leaders cite data literacy as a key to company success, while only 25% of workers actually feel confident in their data skills. And I think data visualization is one of the most fun and exciting ways to start getting people interested in data, because it's a very visual way and a very intuitive way because of those pre-attentive attributes of communicating that information. With our goal being not to just to create a pretty chart, but rather to think about how we can represent data in different ways. We have very kind of beautiful, interesting ways of presenting business data on the left side, this being an award-winning graphic that represents a company's portfolio, but it was used as a postcard for the holiday season. So a very different use case and audience compared to a functional dashboard like you'd see on the right. And so as a data visualization designer, my job is to try to translate these user requirements and needs. As a program manager, I need to know where nurses are using our new mobile application into ideas about what data we would need to build meaningful charts about that specific story. And taking and translating that into the many different charts and graphics that we create, and trying to find ways to continue to bring people and their voices and their hands and their minds into some of these data stories, especially in a world where we have topics like climate change that we need better ways of communicating information about, in terms of communicating things like urgency and individual action. So as we think about this way in which our field has evolved and people are creating more visualizations and charts and graphs, and the integration of AI, I just want to make one more plug to say, please be a cautious but thoughtful consumer and user of these new tools. As even ChatGPT will tell you to make sure to check your facts as you're asking it to pull data sets and generate new charts and graphs. Because building our data visualization design skills and delivering on great data visualizations does more than just inform decision-making at work or in your life. Instead, these skills can help us be more data-informed citizens. So I hope that as you've listened to some of the ideas today in our rapid tour through the world of making data meaningful, that you found a couple ideas of how you can be a more thoughtful consumer of information or creator of charts and graphs. Because we're visual thinkers, we can leverage pre-attentive processing to connect people to patterns and information faster, thinking about how we're using things like color and form and function. And then we also can spend the time, if we're building charts and graphs, just a little bit of time to declutter, add meaningful text and add purposeful color, and making data meaningful by taking care with each of those seemingly small design decisions. And that's a big part of what we do within the Data Viz Society, is bring together conversations as a volunteer-run nonprofit professional association that focus on creating conversations and nurturing the Data Viz world, celebrating the great visualizations in the world, and advancing our industry. And we do that through a journal that happens both in a digital space and in print. We do it through our Outlier Conference, which will be in 2024 at Northwestern University in Chicago. And through things like recognition through the Information is Beautiful Awards, where you can browse an entire entry showcase of 10 award seasons of amazing data visualization work, and dive into more about career paths, the state of the industry, and other themes within the data viz space that I hope you'll take the time to explore. So with that, I'm going to wrap up and leave our last 10 minutes for questions to go ahead and talk through this idea of making data meaningful. I welcome you to go ahead and reach out to me. Feel free to say hi on social media, on LinkedIn, or feel free to shoot me an email. And especially, I guess, if you want that Excel workbook to see how that dumbbell chart got built in Excel. Would also love to have anyone who's really curious about diving into the world of data visualization to come hang out with us within DVS. It is a membership-based organization with both free and dues-paying tiers, and all volunteer run. So it's a real labor of love for me and the other board members. So with that, let's go ahead and dive on over into the world of questions. Emily, where do we want to start with questions? There's some good ones.
There are. Thanks so much, Amanda. That was a really interesting presentation. The first question that we have is one from Carla. Any specific tips you would give high school teachers for developing data awareness in their students?
Oh, that's a great question. So one of my so two things, Carla. So I don't know which field you work in terms of being more on the data side of things or just being kind of more in the data aware, data literacy, reading research type things. But one of the spaces I think is really valuable is to think about how data gets created. And so one of the projects I often recommend people take a look at is a project that Georgia Lupi did called Dear Data. It was a series of 52 postcards that she and Stephanie Posavac sent across the Atlantic between New York and the UK. And the crux of Dear Data is the idea that we can create data sets out of anything in our world around us. And so I think that having high school students actually go through the exercise of creating and collecting quantified self kind of data from the world around them over the course of, say, a week, and then actually sketching or drawing that data using different encodings, color, shape, size. Dear Data is a wonderful space to start in terms of something that someone can do that tangibly helps them think through not just the visualization part, but how data itself gets created in the world and the data in the world around us. I think the second thing to think about as you think about helping that people learn about data visualization and become more data literate is to help people be more critical consumers of charts and graphs. I think that that's one of the most critical skills of navigating social media and the broader kind of media ecosystem these days is thinking about ways to go ahead and be mindful where someone might be misleading you with data. We saw this a lot. I mean, I said my background's public health, right? We saw this a lot in the COVID-19 pandemic with the ways information and graphics were used to misrepresent information. And so I definitely encourage if someone wants to dive in more on a simple, really accessible primer on being a more critical consumer of data visualizations, to read How Charts Lie by Alberto Cairo. It's a really wonderful book that's written for anyone, not just data practitioners. And I think it would be a great thing for a high school student to read to get more acquainted with the ways data visualizations get used both to inform, but also to mislead.
Great, thank you. What a great question, and what a wonderful skill set to provide high school students. Love that. The next comment that we have is no question, just excited to see Amanda and hear all her expertise. This is so interesting. That's from Megan.
Hi, Megan. Thanks.
The next question is, have you ever faced the comment, you're just making the information or data pretty? In my instance, I use our brand guide colors for some data that was pointing out some massive issues. How have you handled this comment and keep people on point and track?
It's a great question in the sense that people say all the time, like all data visualization designers do is just to make data prettier, right? I think that's a really common comment that we get, especially when you're talking about investing time and corollary money in creating better charts and graphs and visualizations. So I have gotten that comment before. I think there are two levels to this question, though, in terms of how it's described. So one is, yes, you hear things about making data pretty. But I think that by presenting back to people a couple different iterations of the same graphic or the same data, whether it's 3 different chart types or a kind of design defaults chart popped out of a tool and then other charts that have been more finessed, you can show people the ways in which you're reducing their cognitive load and helping people engage with the information more effectively by showing rather than telling. I don't want to tell someone like data visualization is important. You can see patterns faster. I want to show you 3 versions of the same graphic and help you see what that looks like. The other thing you called out, though, in that question that I think is a really interesting point is some data is not easy data to read, right? Or easy data to receive. Sometimes data has bad news in it. And sometimes data has bad news that runs counter to what our understanding or perception was of a certain metric or how the company was trending in a certain direction. And so I think there it's really important where you can to have focused conversations with a smaller group of people, thinking about how you go ahead and present that information and making sure that you're thinking about the ways it's going to be interpreted and understood and who the messenger is who's delivering that data. I think it's also a space to think about some of the kind of inbuilt values that we have around what different colors mean. Red meaning oftentimes bad, or orange meaning bad, versus other colors. And so perhaps in that context, someone thought that the color palette that was brought in from the brand style guide made the data look too pretty. And you really wanted to make someone feel a sense of alarm. And so think about the ways in which the text you use and the colors you choose can actually help to create that sentiment or feeling, not just presenting the data in a prettier format.
That's great. I'm thinking back to your example of the women who joined sororities and the different ways that you presented that, and the perception, I think, would be really different depending on which visualization you
Yeah.
used.
Well, even 20% versus 1 in 5, right? Like the way we feel.
Mhm.
There's interesting research from the 80s about this in terms of how frequency framing prompts us to think very differently about how big or small something is. If I say 1 in 5 people is going to develop a cancer in a lifetime versus 20% of people, 1 in
Mhm.
5, I feel like, oh my gosh, like that could be someone at my dinner table. 20% feels like, oh, that's can be other people. And I think in
Right.
healthcare, we think a lot about that in terms of how people see themselves in statistics, especially when communicating about things like risk.
That's really interesting to think about. Megan has asked if you would repeat the book title that you recommended,
Yeah.
please.
The book title there, How Charts Lie. It is an excellent book. All of Alberto's books are excellent, all 4 of them. But it is one that's written for non-data people. If you're interested in diving into that idea of how to kind of get smarter about reading graphs and charts, it's also, I think, a really good book in the sense that it does walk through and give you kind of a stepwise, by the end, kind of framework to think about that you can go into and read charts and graphs with a little bit more care than you might have before. I know I even learned new things going ahead and reading that book and getting to sit on a panel with him at the Urban Institute.
Very cool. Thank you.
Yeah.
The next question is, do you have any recommendation for resources on color theory, etc.?
Color theory. Oh, such a delight. So I do. And I'm going to fail at pulling this up. So JJ, maybe you can behind the scenes make magic happen for me. Data Wrapper is a platform that is a wonderful web-based data visualization authoring tool for building embeddable charts and graphs. And it is a wonderful authoring tool. It also has a tranche of amazing resources, especially on color, written specifically by Lisa Charlotte Rost. She is someone who has written entire blogs and curated them into a whole series on color and color theory in the world of data visualization. She's working currently on a book on the topic that will package all that wonderful knowledge up. But she and her work and her writing is the first place I go for kind of accessible, applicable ideas on color and color theory. So if you look up Data Wrapper and color resources, I promise it'll pop up. But it is a wonderful tranche of resources. There's older things and things like Maureen Stone's work and research from Tableau Research that focus a lot on kind of the really detailed nuances and research around color. But I think it's a little bit less immediately applicable than some of the writing and work that Lisa has done. So highly recommend her writing and resources on that. And she links out to a tranche of other things. So start there to not get overwhelmed, and then go follow your way through the internet and all the other things you can dive into.
Great, thank you. And Amanda, can you tell us one last time where we can find you online?
Sure. So easiest place to connect with me is currently on LinkedIn. I also am on Twitter, but less active by the day, and have been shifting over a little bit onto Blue Sky. But the best place to share and connect is on LinkedIn, or by joining the Data Visualization Society and connecting with me there on our Slack, or in other ways through DVS.
Excellent. Thank you so much. We really appreciate your time today, and thanks everyone for tuning in to watch this fascinating webinar. As a reminder, a recording of this webinar will be available on our website later today. You can see this and all of our other webinar presentations at www.alumlc.org/MiamiOH. And for more information about Miami Women, please visit miamialum.org/Miami Women. Thanks for joining us. Thank you, Amanda. Love and honor.
Thank you so much. Thanks for having me. And thanks to everyone who tuned in. I hope that you've been inspired to go do some really fun data visualization work, and happy plotting.
Thank you.